The video is about the software process. So in this video lecture, the detail about the software process and different software process model will be discussed. A software process is a structured set of activities required to develop a software system. Many different software processes, but all involve these four things common. First is the specification. We define what the system should do. This means we must have a specification, or we can say software requirement specification. Design and implementation. Defining the organization of the system and implementing the system. Validation, which checks that it does what the customer wants or not, or we can say that the desired system meets the functionalities of the users or not. And then evolution, changing the system in response to changing customer needs. A software process model is an abstract representation of the process. So we need a proper process model. So it represents a description of process from some particular perspective. Software process description. When we describe and discuss software processes, we usually talk about the activities in these processes, such as specifying a data model, designing a user interface, and ordering these activities. There are basically two types of approaches. One is plan-driven and other is agile process. Plan-driven process are process where all of the process activities are planned in advance and progress is measured against this plan. So this means we finalize all the activities, all the functionalities, all the user requests in the form of specification in plan-driven approach, while in agile process planning is incremental and it is easier to change the process to reflect changing customer requirements. So changes can be expected. User might not agree with some functionalities, or the changes can abruptly be expected throughout the development. So it is not a planned process. In practice, most practical processes include elements of both plan-driven and agile approaches. There are no right or wrong software process. We cannot say that the particular process model or process is wrong and this is correct. This depends on the scenario, circumstances. This depends on the user's demands, and then accordingly we apply the best suitable process model. Now come to discuss about the software process model. We have these few process models. The waterfall, it is a plan-driven model, separate and distinct phases of specification and development. V model provides a way of visualizing how verification and validation actions. Incremental development includes specification, development, and validation are interleaved. May be plan-driven or agile. So incremental can be plan-driven or agile. Integration and configuration model. This system is assembled from from existing configurable components, may be plan-driven or agile. So agile include both the approaches. This means if we are adopting agile, laterally we will discuss about it. So this means the development will be incremental and there must be integration and configuration involved. In practice, most large systems are developed using a process that incorporates elements from all of these models. Now come to discuss about waterfall process model. This is the basic structure of the waterfall. Here you can see requirements are defined, means requirement list of requirement are finalized, specified, and then come to the design phase. System is design, and then come to the implementation and unit testing. Unit test each component, the code of each component is tested. So in order to check, in order to validate that the functionalities are correct or not. Then come to integration and system testing. What is happening in integration? In integration, two or more than two components, or we can say two or more than two modules are integrated, and then we do the integration test and system testing, and at the end software is deployed, and then maintenance phase come. So in maintenance phase, the problem can be in here, so we can come to this phase, we can come to this phase, can be to this phase, and can be to this phase. So this is the basics of waterfall. Why it is called waterfall? Because it come to this stage, and after finalizing this phase we come to this phase, and then so on. There are separate identified phases in the waterfall model: requirement analysis and definition, system and software design, implementation and unit testing, integration and system testing, operation and maintenance. The main drawback of waterfall is the difficulty of accommodating change after the process is underway. In principle, a phase has to be complete before moving on to the next phase. This means, like a waterfall, when waterfall, like example of raining, when waterfall, so difficult, so it is the water, the direction of falling water is toward earth, so it cannot go back. Why this happens? Why we cannot go back? If somebody asks you that if software is implemented, completely deployed using waterfall method, and we need to do some changes, or during development, if we analyze something is wrong, something is missing, something is not correct, and we go back, like if we realize something here and we want to go back to previous phases, so we cannot go. No, we can go, but the problem is that the problem mostly comes here in the design. So here we finalize the design, so laterally the changes in this design can become much costly. So thus if we implement the software using waterfall and we have to bring some changes, then this means we must have to accommodate changes first in the designing, and that become difficult, because the designer the model is given to the designer, and then designer do designing based on that model, and he know that changes will not be accommodated or not expected from the user. The main problems include inflexible partitioning of the project into distinct stages, make it difficult to respond to changing customer requirements. Therefore, this model is only appropriate when the requirements are well understood and changes will be fairly limited during the design process. Few business systems have stable requirements. This means you must be careful before adopting this model, where you are 100% sure that changes will not occur, or some business, if you are developing the business oriented software, so you must know that changes will not occur and the requirements are stable requirements. The waterfall model is mostly used for large system engineering projects where the requirement is developed at several sites, but it is not mandatory that we should apply it for either small or large systems projects, but one thing is you should remember, one thing is fixed, that is the stable requirements. In those circumstances, the plan driven nature of waterfall model helps coordinate the work. Now come to discuss about the V process model. Why it is called V? Because the shape is like a V. Here, during the requirement engineering phase, or we can say requirement modeling, because when we collect the requirements, we then model these requirements using different available models. So we plan for the acceptance testing. And then when the software is implemented, deployed, the end test, the final test is this acceptance testing. So if we look the shape, it comes first to the requirement modeling, then architecture designing, component designing, code, and after unit testing we do integration testing, system testing, and then acceptance testing. So it is like this, it comes like this, but in parallel we plan for the acceptance testing because the requirements are not yet implemented, but we plan for the acceptance testing. And acceptance testing is also called user acceptance test or user test. Then also along with the acceptance test, we plan for the system test. In system test, we as a whole test the whole system against the specification document as designed during the requirement engineering phase. So system testing involve the testing of the whole functionalities of the software, or we can say system testing comprise of the functional tests. So during modeling we plan for acceptance testing and system testing. Then after requirement modeling we come to the architecture designing, where we design the architecture, and here in parallel we plan for the system test. So system test is to validate both the requirement modeling and architecture designing and integration test, because different components of the system are connected, so we also check that thing. Then after designing after the architecture designing we come to the component designing. Component designing is also called low level design, and architecture designing is also called high level design. So we can say high level design and low level design. So on low level design we design a classes, the components, and then we plan for the unit test, because through unit test we test the particular component, and integration test. So integration test is necessary because two or more than two components or classes are based on the object oriented programming concepts cannot be tested in isolation, but it also include the integration testing. And then code generation, or we can say an implementation phase or coding, where we plan just for the unit test. Then after the coding we do the unit test against this code, and then integration test to validate the component design, and then system test to validate the architecture design and also the requirements of specification document, and then acceptance testing at the end. So that's why due to the planning of different test, or we can say designing different test cases in parallel with different phases of this software development life cycle, we call it as a V model. V model, a variant of waterfall model. We can say it is a variant of waterfall model, uses unit testing to verify the procedural design, uses integration testing to verify architecture designing, uses acceptance testing to validate the requirements. If problems are found during verification and validation, the left side of the V can be re-executed before testing on the right side. Verification and validation VNV. We can also call V model as a VNV model because it includes the verification as well as validation. As I stated, verification means are we building the product right? This means verification is a process oriented approach, that are we building the product in a right way. So verification is a process of checking that software achieve its goal without any bugs. It is the process to ensure whether the product that is developed is right or not. It verifies whether the developed product fulfills the requirement that we have. So this means for checking the requirements, we normally do the verification. And validation means are we building the right product? This means we will validate the end product. Validation is the process of checking whether the process product is up to the mark, or in other words, product has high level requirements. It is the process of checking the validation of product, that is, it checks what we are developing is the right product or not. It is the validation of actual and expected product. Use cases for the V-shaped model. This model is used in the medical development field as it's strictly a discipline domain for the projects where an accurate product testing is required. For small to medium sized project where the requirements are strictly predefined, the engineers of the required qualification, especially tester, are within easy reach. So because of the too much test cases, so test engineers are required. Advantage: testing and verification take place in early stages. Now come to incremental model. This is the basic structure of incremental model, where based on the outline description, specification, requirements, the specification of the software is finalized, or we can say the specification document is finalized. Then based on specification, we develop or implement the software, and then come to the testing or validation phase, where the end product or the desired product is tested. So if there is some error, some problem, so we can fix that thing and go back to the development phase. And if something is missing in the specification, so we can go then back to the specification, and then based on the new changes or corrections or modification, we do implementation and then validation. So in incremental, we develop the whole software in increment. For example, if we are going to develop the software in 3 increments, so we can say increment 1, increment 2, or increment 3, or initial version, intermediate versions, final version. So incremental model basically focus on delivery of the software in increments, and this thing should be specified earlier before the development, during the specification phase, that and this must include the stakeholder. So this means we must have to take the opinion from the user before adopting this incremental model. Normally this model is applied adopted for the large systems which include too much modules, or we can say maybe in present time the user don't need all the modules. So adopting incremental model, we can deploy the software in increments rather than as a whole one package. Incremental development benefits: the cost of accommodating changes customer requirement is reduced. The amount of analysis and documentation that has to be redone is much less than is required with waterfall, because in waterfall all the modules are specified in advance. so the specification detail of each and every module as a whole system is finalized. But here we don't go in detail of each increment, just we define the scope, but we don't go in so much detail, and thus that is the benefit. Another benefit is that it is easier to get customer feedback on the development work that has been done. Customer can comment on the demonstrations of the software and see how much has been implemented. So based on the initial version, more and more good suggestion and comments can come from the users. So laterally you can fix that thing, or in upcoming version you can keep that thing in mind. More rapid delivery and deployment of useful software to customer is possible. Customers are able to use and gain value from the software early. That is possible with earlier than is possible with waterfall. So as compared to waterfall, customer can be able to use and gain value from each software early. So that is the advantage. Another model similar to this is the iteration model, where you release the software and then based on the user demand you then iterate and then add some more functionality over the time. But that is different logic from the incremental. In incremental, mostly the modules or the functionalities are wholly implemented, rather than we will iterately change that thing, and then based on the opinion then you develop more functionalities, separate independent functionalities, and then you integrate. Now what are the problems with this model? System structure tends to degrade as new increments are added. So this means you have to alter the structure when you develop new versions and then you integrate, unless time and money is spent on refactoring. Refactoring is basically to change the code structure, or we can say to make it more beautiful or useful. So unless time and money is spent on refactoring to improve the software, regular change tend to corrupt its structure. So this means money and time is required to corrupt, to change the structure, the basic structure of the code. Incorporating further software change is becoming increasingly difficult and costly. So that is the main problem with the incremental model. Integration and configuration based on the software reuse, where the systems are integrated from the existing components. So reused elements may be configured to adopt their behavior and functionality to user requirements. Reuse is now standard approach for building many types of the business system. So in integration, we mainly apply the reusing property. Integration basic concept is to integrate the two modules or two or more than two components. So if we have developed this components, the software in component, so we can easily reuse that components and make integration of that with the existing features, and then we configure to make it practical for the use. Now prototyping model, which is very interesting. This is the prototyping model where you develop or design the prototypes rather than the actual software. What is here? First you come together the requirements, and then software designing is finalized, software architecture and design is finalized based on the collected requirements, and then you design a prototypes rather than start a coding based on the software design for the collected requirements. You build prototypes, then you evaluate the prototype from the customer or users. If he is agree, he is satisfied, then you start coding based on that design. Or if he is not agree, or he or she want to make it change, or maybe some functionalities more are required, or changes are required, so requirements are refined, and then you go back to designing phase. So this, from this prototypes and prototype evaluation, you refine the requirement list and then design, and then go back to this phase. You then make more prototypes, or we can say the enhanced prototypes, and you then evaluate it again. And if the requirements are okay, so based on the new designing, the new designing, you start coding and testing, and then release. So there are a lot of advantage of prototyping. The much of the development time is reduced, especially when you are applying the incremental approach, or laterally when we discuss about the agile. So prototyping is very much helpful because no coding is involved here, and the whole software can be designed using prototypes, and then customer feedback can be taken on the time, and thus you design and deploy the software easily. Then prototyping can be considered as a requirements collection technique. Laterally, when we will discuss about the requirement engineering phase, so prototyping will be discussed as a requirement elicitation technique. Through this, we collect requirements. Like here you can see the customer evaluation. So customer evaluation means you discuss the requirements or software design with the customer. Prototyping is a limited representation of designing that allow users to interact with and to explore its suitability. It allows stakeholders to interact with the envisioned product, gain some experience of using, and explore the imagined uses. Production of an intermediary product to be used as a base for testing. Aim is to save money and time, as I discussed in the previous slide. Aim is to have something that can be tested with real use. You never get it right first time. If at first you don't succeed, then you redesign that thing again. So that is the same thing in the last diagram. Designing, and then you, based on the software designing, you design the prototypes using any tool. For a lot of tools are suggested and available freely on internet, so you can download it and make design, and then evaluate. If okay, done. Not, then redesign means here you change this design, and then based on the design you develop the prototype. So after redesigning, then you designing the prototypes again, or you change their prototype, and then you evaluate from the your customer or user. If it is okay, then you go further to the next step. You can see this is the prototype of mobile application. So from this huge amount of lists or specification, you design this prototype, and then you evaluate it from the user. What is a prototype? In interaction designing, it can be of the following: a series of screen sketches, a storyboard, that is cartoon-like series of scenes, a PowerPoint slideshow, a video simulating the use of system, a piece of software with limited functionality written in target language or in another language. But there are now, in modern era, there are advanced tools available to design both static prototypes and dynamic prototypes. There are two categories of prototypes. Static, here we only design the shape of the software or like the interface, where we cannot make the dynamic activities like save, insert, selection, searching. But in dynamic prototype we can set values like it will work as actual software, but that is not actual software, and no coding is there, so that looks like the actual software. And in dynamic prototype we add the dynamic events. These are the steps. Build step. A prototype of basic functionality, especially the interface, is built. Test the prototype, which will uncover the design errors, correct the errors, repeat. Why prototype? Evaluation and feedback are central to interaction design. Stakeholder can see, hold, interact with the prototype more easily than a document or drawing. So it actually interact or attract the user. So user see that how their software will look like. So using prototypes we can easily satisfy our team or customer, so or can get confidence on the design, so team members can communicate effectively. So not necessarily it is only for the users, but for team member it is also the good approach to design the prototypes. You can test out ideas of yourself. When you have some ideas in mind, you can test that ideas. It encourages reflection, very important aspect of design. Prototypes answer questions and support designers in choosing between the different alternatives that are possible. So this means a good negotiations can be possible using prototypes. Laterally when we discuss agile, so the best option for us is to the design prototypes rather than the actual functionality. And then you from user evaluation you then start implementing that thing in actual. Benefits of prototyping can be best used to test every detail of the final product before the product is built. Results in higher user satisfaction. Users are better at evaluating an existing described system. It brings the user into the process early. There are basic two types of the prototypes model. Evolutionary, the prototype can be evolutionary or throw-away. Throw-away or evolutionary prototypes are those that are built, tested and throw-away, useful in early stages. Knowledge gained contribute to final system, or we can say to next prototype, and can be expensive. The prototype is used to get the specification right, then discarded. So this means these are once developed, designed, and after finalizing the designing or requirements or get the feedback, we then discard that thing, that prototype. So that is not useful then in next designing or development phases. But in evolutionary prototypes are those that are not discarded but serve as a basis for the next iteration of the designing. Danger of initially bad designing persisting. The prototypes are eventually becomes the product, and that prototypes are evolved over the time. So then we take guidance from that updated prototype. So evolutionary prototypes are not discarded, but we do bring changes in that prototypes over the development life cycle. That was up to today, and hope you enjoyed my lecture. Next video lecture we will come with some more good topic. So thank you for watching my video. Thank you so much.